the Voyager 2 spacecraft has finally bid farewell to our solar system, and it's entered the realm of the unknown.
Voyager 2 was never built to turn back, so when its instruments shifted, without command, without malfunction, scientists were left with more questions than answers. Something out there, past the edge of our solar system, may have triggered a response, not from Earth, but from them. The data wasn't random. The silence that followed wasn't accidental, and one long whispered theory, long dismissed, now reconsidered, sits squarely in the middle of it all. What if we were never the explorers? What if we've always been the exhibit? Something just blinked, and Voyager caught it, but it's not what it saw. It's what might have seen us. A non-mechanical turn. When engineers monitoring Voyager 2 noticed a subtle shift in its data transmission pattern, they initially assumed a fault in the onboard systems. After all, the spacecraft, launched in 1977, is decades past its expected lifespan. But what occurred wasn't mechanical, it was operational. The probe didn't change course, it changed what it was paying attention to. Specifically, Voyager 2 reoriented its functional instruments, particularly the plasma wave subsystem and the magnetometer, toward a fixed region of interstellar space. This redirection wasn't scheduled, nor was it consistent with any known automated behavior. For a spacecraft with limited remaining power, such an allocation of energy is significant. Why would it choose to prioritize observation in a particular direction, unless something had triggered its sensors in a way that required response? This wasn't just an operational anomaly, it was a behavioral shift. While Voyager 2 operates semi-autonomously, its programming hasn't been substantially altered in years. It lacks the capacity to make novel decisions outside of preset parameters. So when the data revealed a coordinated shift in sensor orientation, it raised immediate concern among scientists at the Deep Space Network. Telemetry logs showed the plasma sensors had begun operating at intervals inconsistent with any Earth-based command. The change was subtle, yet deliberate. It's not uncommon for spacecraft to recalibrate when encountering new environments, but Voyager had long passed the heliopause and was presumed to be in a relatively uniform interstellar medium. What exactly had prompted this reconfiguration? Adding to the mystery, this sensor redirection coincided with an uptick in low-frequency electromagnetic activity. While not extraordinary in isolation, the timing raised questions. Was Voyager reacting to something local in interstellar space, or had it detected a signal so compelling that its programming prioritized it? Researchers hesitate to speculate, but comparisons to similar automated behaviors in earlier mission phases showed no precedent for such a response. Voyager's systems are programmed to conserve power and limit activity, making this deviation statistically improbable without an external catalyst. The odds of such behavior being random were low enough to rule out malfunction as a primary cause. One of the most compelling aspects of this event is what it suggests, not about the spacecraft, but about the environment around it. A non-mechanical turn implies recognition, or at least stimulus. Without propulsion or steering capabilities, Voyager can only turn by choosing what it listens to, and in this case, it listened to something. The unsettling question that follows: what kind of presence or emission out there warranted that kind of attention? Was this a response to detection, or a sign of being detected? Just when the redirection seemed strange enough, the data it captured turned everything on its head. A signal too precise to ignore. Following Voyager 2's unexpected sensor realignment, researchers began closely examining the incoming data. What they found was unlike anything previously recorded from the interstellar medium. The probe's plasma wave subsystem and magnetometer began detecting electromagnetic fluctuations that were highly structured and repetitive. These weren't random bursts or background interference from solar activity. Instead, the signals displayed characteristics resembling artificially generated patterns. Frequencies arranged in intervals with mathematical symmetry. Most notably, one recurring pulse lasted exactly 3.142 seconds before repeating, an unmistakable representation of the mathematical constant pi. In a vacuum, such precise regularity, particularly one referencing a universal constant, is not consistent with known natural processes. Further analysis applied Fourier transformations and signal deconvolution techniques to isolate underlying patterns. The results revealed nested harmonic structures and frequency spacing consistent with engineered communication systems. These were not analogues to human language, but mathematical sequences, clean, intentional, and persistent. Unlike previous anomalies that could be attributed to equipment noise or signal drift, these patterns repeated at consistent intervals across different instrument modes and with clear binary-like structures. Some scientists likened them to rudimentary computational packets, stripped of content but embedded with markers, headers, pauses, and checksum-like repetitions. Their complexity hinted at a sender with an understanding not just of physics, but of signaling theory. The magnetometer data added another layer of concern. Subtle, low-frequency modulations in the magnetic field were synchronized with the plasma wave patterns. This cross-instrument correlation reinforced the idea that the signal was not just detectable, it was being deliberately broadcast across multiple physical channels. That level of precision would require control over both electromagnetic emissions and local magnetic fields, something far beyond our current capabilities. The signal also lacked distortion, consistent with distance-based degradation, suggesting that whatever was transmitting it was either very close, very advanced, or both.
Distant human-made object in the universe is sending usable information to Earth.
The absence of any natural source in the direction of origin deepened the puzzle. Speculation within the scientific community began to shift. Could this be the response to humanity's earlier interstellar broadcasts? Was Voyager 2 being used as a test platform for a type of reply, one that avoids linguistic ambiguity by anchoring itself in universal mathematics? No one could answer definitively, but one fact remained undisputed. The patterns were real, intentional, and pointed. Voyager 2 had picked up something crafted with logic and precision, and that raises a question science isn't prepared to answer yet. Who or what wanted to be noticed? Interference patterns and gravitational distortions. While the signal Voyager 2 picked up drew immediate attention, it was the probe's trajectory and timing anomalies that added a deeper layer of concern. As the probe continued to transmit data, scientists observed slight but measurable deviations in its expected path, anomalies that could not be explained by known gravitational sources. These weren't sudden course corrections or system malfunctions, rather they appeared as persistent, low-intensity drifts, almost like the spacecraft was being nudged by an unseen force. The changes were small, but consistent enough across multiple datasets to eliminate random error. This raised the possibility that Voyager 2 was experiencing the effects of gravitational distortions in space, ones not accounted for by any celestial body within known proximity. Using predictive models based on Voyager's mass, velocity, and known gravitational fields, analysts at the Jet Propulsion Laboratory ran simulations to find a match for the observed trajectory changes. None fit. Eventually, the data began pointing toward a more speculative explanation: gravitational lensing. This phenomenon, often observed around massive objects like black holes or galaxies, occurs when space-time itself is warped, bending the path of light or objects. But Voyager was not near any known mass concentrations large enough to cause such an effect. If lensing was occurring, it implied one of two things: either something massive and hidden was nearby, or gravitational effects were being generated through non-standard means. Compounding this were irregularities in Voyager's signal timing. The Doppler shift, which is used to track changes in spacecraft speed and position, revealed brief inconsistencies, delays, and advances in signal return time that didn't align with Voyager's known motion. Initially suspected to be the result of interstellar plasma interference, further analysis ruled this out. The signal fluctuations didn't match any profile associated with solar or interstellar particle events. Instead, they formed a subtle pattern, oscillations that hinted at interference, possibly from multiple sources. It was as if Voyager's transmissions were reflecting off or passing through transient fields, something more structured than space dust or gas clouds.
Couldn't regain control of the lost Voyager 2 probe after a heartbeat signal was picked up.
These telemetry inconsistencies forced mission controllers to consider the possibility that Voyager 2 had entered a region of space influenced by objects or phenomena not catalogued by current astrophysical models. Could there be a network of masses, small or cloaked, that distort gravity just enough to register over time? Or was there a more advanced mechanism at play, one capable of manipulating local space-time without emitting detectable energy? Either scenario challenges the current understanding of interstellar space and suggests Voyager may have stumbled into an environment far more complex than previously believed. Surveillance, not contact. The abrupt end to the structured signals Voyager 2 had been detecting raised an unsettling possibility. This was not a miscommunication or a technological failure. It was a deliberate termination. When the probe's instruments went quiet shortly after recording coordinated electromagnetic and magnetic anomalies, analysts first suspected a malfunction, but internal diagnostics showed no signs of equipment degradation. This sudden silence did not resemble random interference or signal drop. Instead, it mirrored behavioral patterns observed in strategic intelligence operations, specifically passive monitoring that ceases once the subject is aware of being watched. In this context, the termination of the signal seemed less like the end of a broadcast and more like the closing of a one-way observation channel. This interpretation led to a re-evaluation of the entire sequence. If what Voyager 2 encountered was not an attempt at communication, then it may have been surveillance. The behavior resembled an intelligence-gathering mechanism, possibly automated, that initiates monitoring upon detection and disengages once its objective is complete. No message followed, no continued attempt to interact, just structured data, followed by silence. In terrestrial military and intelligence practices, this is consistent with reconnaissance, observe, log, disengage. If this logic applies, then Voyager was not selected for conversation, it was selected for analysis. And that distinction carries significant implications. Another layer of concern emerged when researchers noted the pattern of the signals stopped just after increased scrutiny began from Earth-based observatories. It's as if the signal's origin became aware that its presence had been noticed, not just by Voyager, but by Earth. That kind of behavioral adaptation implies a level of situational awareness. More troublingly, it suggests this was not an accidental encounter. The timing, modulation, and eventual termination of the transmissions resemble protocols designed to minimize detection while maximizing data collection. This idea that the observers are not just watching, but aware of being observed in return, creates an asymmetric interaction. They gather. We react.
Voyager 2 was the one that was chosen to do the grand tour, that is, to fly by Jupiter.
No threatening act occurred. No probe was disabled. But what alarms analysts isn't what was done, it's what wasn't. No response was issued to Voyager's golden record. No sign of intent was offered, just passive observation, followed by a strategic withdrawal. And in that silence lies the unnerving conclusion. If there is intelligence behind the signal, it may not be interested in dialogue. It may already have what it came for. And that raises a critical question. If this was surveillance, what exactly was it trying to learn about us? And more importantly, what happens now that it has? Anomalies from the past. In the wake of Voyager 2's recent anomalies, researchers began revisiting archival data from earlier deep space missions. The goal was straightforward: determine whether similar patterns had ever occurred but gone unnoticed. What they found was both surprising and deeply unsettling. Data from Pioneer 10, Voyager 1, and even Cassini contained subtle irregularities, minor signal distortions, unexplained timing offsets, and low-frequency spikes, none of which had been flagged at the time. Viewed in isolation, these anomalies had been dismissed as background noise or minor hardware faults. But now, placed beside the Voyager 2 findings, they formed a disturbingly consistent pattern. The conclusion was difficult to ignore. The phenomenon Voyager 2 encountered might not be new. It might have been present for decades. A particularly compelling example emerged from the Voyager 1 archive. In multiple instances during its journey beyond Saturn, telemetry logs show unexplained low-frequency pulses occurring in consistent intervals, patterns that, at the time, were attributed to solar activity. However, modern filtering techniques applied to this data revealed structured frequency relationships strikingly similar to what Voyager 2 recently recorded. These weren't bursts of random energy. They exhibited spacing and repetition, indicative of intention, not noise. Cassini's magnetospheric data near Saturn, once written off as statistical artifacts, also showed recurring waveforms when reanalyzed through today's refined algorithms. The fact that these anomalies were buried in massive datasets and only now detectable with advanced machine learning and signal processing tools raises troubling questions. Have we been observed far longer than we realized? And if these anomalies are indeed consistent across multiple probes and mission timelines, it suggests something else entirely, that whatever is monitoring it has been doing so methodically and patiently. The absence of overt contact could have been a choice, not a limitation. Each spacecraft might have passed briefly through the periphery of a larger system, an observational field, or perhaps a perimeter established with purpose.
Finding the probe's carrier signal, NASA was able to confirm that Voyager 2 is still broadcasting.
This long-term observation theory shifts the narrative from a recent discovery to a retrospective realization. If Voyager 2's event was the latest in a quiet, ongoing pattern, then it may not represent a beginning, but a threshold, one that's only now being recognized. These echoes in the data don't point to a single incident. They suggest a timeline, one in which humanity's presence in space has been quietly catalogued, not for years, but for generations. The unsettling part is not that we've just been noticed, but that we were never truly alone, and we failed to notice first. Those quiet patterns in the past may not have been random, and now we're starting to see where they were coming from. A hidden boundary. The Oort cloud has long been regarded as the cold, distant shell of icy debris encircling our solar system, a boundary zone between our star's domain and the true interstellar medium. Yet Voyager 2's anomalous data has prompted scientists to reconsider this view. What if the Oort cloud isn't just a natural feature, but a strategic boundary? A growing number of researchers now propose that the outer edge of our solar system may serve as more than a gravitational threshold. It could function as a monitored perimeter, potentially watched or even patrolled by something non-terrestrial. The sudden burst of structured activity detected by Voyager 2 as it passed into this region raises the possibility that it may have crossed an invisible line, one not defined by physics alone, but by intent. This speculation is not based on conjecture alone. The characteristics of the Voyager signal shift coincided almost precisely with its approach to the far edge of the solar system, near the outer reaches of the heliosphere, where solar wind gives way to the interstellar environment. Although the Oort cloud itself remains unvisited and largely unmeasured directly, its estimated scale and mass distribution could theoretically provide cover for objects, constructs, or technologies capable of passive observation. Unlike the inner solar system, which is regularly scanned and mapped, the Oort cloud lies in relative obscurity, difficult to monitor and almost impossible to survey in detail. That obscurity may not be a coincidence. Supporting this idea is the fact that the signal and trajectory anomalies detected by Voyager 2 did not appear to originate from deep interstellar space, but from somewhere within or just beyond the heliopause. Some analysts have begun considering the idea of a distributed monitoring system, possibly a network of stations or beacons embedded in the periphery of the Oort cloud. These could theoretically be autonomous, passive, and capable of triggering a response, or silence, when activity like Voyager's crossing is detected. If true, that would mean our solar system may be under observation from its outermost edges, not in open hostility, but in quiet awareness. The Watchers may be positioned where we've rarely looked, just far enough away to avoid detection, yet close enough to monitor us continuously. The implications of such a monitored boundary are significant. If there is an observation grid, or even a single sentinel in or near the Oort cloud, then the Voyager missions may have inadvertently activated a protocol we were never meant to encounter. It reframes our outer solar system not as the end of our reach, but as the beginning of someone else's. In that sense, the silence beyond may not be due to emptiness, but to purpose, watching, waiting, and hidden in plain view. Beyond our reality. One of the more complex and controversial interpretations of the Voyager 2 anomalies suggests that the spacecraft may have interacted with a phenomenon not entirely confined to our observable dimension.
Voyager 2 is the first interstellar mission of humanity.
While this idea pushes the boundaries of current astrophysics, it is not without precedent in theoretical frameworks. Scientists analyzing the electromagnetic disturbances and spatial distortions recorded by Voyager 2 have raised the possibility that the probe may have encountered a localized disruption in the quantum vacuum, an effect difficult to explain using only classical physics. Subtle shifts in background particle noise and low probability fluctuations point toward changes not in space itself, but in the properties of space, potentially hinting at the presence of exotic matter or a dimensional interface. Quantum physicists involved in post-event analysis noted brief variations in the local quantum field state detected through indirect signal effects. These fluctuations were non-random, repeated at irregular but patterned intervals, and appeared to influence Voyager's signal behavior and timing. This kind of localized vacuum manipulation would require control over the zero-point energy field, a concept still theoretical, but increasingly explored in advanced physics. Such a disturbance, if real, suggests either a naturally occurring breach in dimensional uniformity or the influence of a technology capable of operating across layers of physical law we don't yet fully understand. Another line of inquiry focused on the possibility that Voyager 2 intersected with a structure or entity that does not exist entirely within three-dimensional space. In theoretical physics, higher dimensional models, such as those proposed in string theory or brane cosmology, describe the universe as composed of more than the four dimensions we experience. If a structure were partially extruded into our dimension, much like a shadow from a higher dimensional object, it might create electromagnetic and gravitational anomalies without revealing its full form. Such an interaction could explain the temporary but profound disturbances Voyager recorded, as well as the lack of visible confirmation through telescopic instruments. While speculative, this interpretation aligns with the otherwise unexplained nature of the observations. No known object or phenomenon fits all the data Voyager 2 transmitted. The idea that it may have briefly intersected with or been affected by a region where our physical laws become unstable or are altered by external control remains unproven, but it is under active investigation. The central question remains: if such a dimensional interface exists, was it a naturally occurring anomaly, or did something put it there? Voyager may have provided more than data from deep space. It may have offered the first measurable sign of a reality deeper than our own. EM signature has changed. For decades, Earth has been steadily increasing its electromagnetic EM emissions, from analog radio waves in the early 20th century to today's high-frequency, broadband digital signals.
Of everything. NASA feared the worst, that the 1977 spacecraft had finally gone.
This cumulative rise in planetary noise has fundamentally altered Earth's electromagnetic footprint in space. While most of this output was previously lost in the background of cosmic radio chatter, some researchers now speculate that we've crossed a threshold, one where our signals are not only stronger but more organized, making them easier to isolate and interpret. Voyager 2's recent anomalies may not be a coincidence, but a delayed reaction to decades of growing electromagnetic activity. In this view, our increasing digital saturation may have finally made us too noticeable to ignore. What changed? It's not just the volume, but the structure of our transmissions. Satellite constellations, global internet infrastructure, and machine-to-machine communication have led to continuous, patterned emissions. Unlike earlier decades, today's signals include error correction, digital handshakes, and persistent pings, elements that could stand out to any passive monitoring system designed to look for technological signatures. Some experts have proposed that Earth's electromagnetic emissions may have finally reached a density or coherence level, interpretable as intentional rather than incidental. If so, this might explain why a reaction detected indirectly through Voyager 2 happened now and not 20 years earlier. Adding weight to this theory are models from SETI researchers and techno-signature analysts, who've long speculated that advanced civilizations might use algorithms to scan space for emerging patterns of unnatural origin. By that logic, Earth's electromagnetic emissions may have matured into a recognizable signal type, a form of synthetic coherence indicating intelligent infrastructure. If someone or something has been listening, it may not have acted until that signal crossed a preset threshold. This could even align with a kind of monitoring protocol triggered by shifts in our activity, suggesting that the signal Voyager 2 intercepted wasn't random. It was a reaction to a milestone we unknowingly reached. This raises difficult questions. What if the Watchers, if they exist, weren't looking for life, but for a specific kind of behavior? Perhaps they monitor for civilizations that reach a certain level of systemic electromagnetic complexity, interpreting it as readiness or risk. If Voyager 2's redirection and the accompanying signal burst correlate with our digital signature becoming unignorable, then the real concern isn't what we've discovered in space. It's what our own technological evolution has revealed about us and who might now be paying attention. Signals within the solar system. The most recent data has shifted the conversation from the distant cosmos to our own celestial backyard. Scientists analyzing low-frequency spectrometer data from observatories and space-based instruments have begun detecting strange, repeating oscillations originating not from deep space, but from within our solar system. These signals, though subtle, are persistent. Disturbingly, several appear to be emanating from regions near planetary orbits, specifically around Neptune, and even more puzzlingly, near Mars.
Cute photos of our neighboring planets, Jupiter, Saturn, Neptune, Uranus.
This proximity calls into question many previous assumptions. If Voyager 2's encounter was a result of external surveillance, why are we now finding similar anomalies inside the boundary of our own solar system? The signals in question aren't traditional transmissions. They manifest as magnetic ripples and structured, low-frequency pulses that don't match known sources such as planetary magnetospheres or solar interference. Some of the readings near Neptune were initially thought to be echoes from solar wind interactions with the planet's magnetic field, but their precise periodicity and apparent directional origin rule out natural causes. Likewise, instruments on Mars orbiters detected field distortions that couldn't be accounted for by either solar activity or Martian geology. These aren't one-off spikes, but coordinated patterns, timed, deliberate, and spatially consistent. If they are signals, their presence this close is a game-changer. What's most alarming isn't just the presence of these anomalies, but the possibility that they've been ongoing and only now detectable due to improved instruments. Earlier technologies may have lacked the sensitivity or resolution to distinguish them from cosmic background noise. But today's tools, especially those using machine learning to filter complex data, reveal that these distortions aren't evenly distributed. They cluster near planetary bodies, as if gravitating toward mass or electromagnetic fields. This suggests two possible interpretations. Either the source is using planets as anchors for observation, or it's interacting with them in a way that produces detectable artifacts. In either case, the implication is hard to dismiss. Whatever is generating these anomalies is already inside our system. This realization reframes the entire narrative. The idea that we're being watched from afar is unnerving enough, but evidence now suggests that observation, or presence, may already exist within the solar system. Whether these signals come from automated probes, cloaked monitoring devices, or some form of passive field manipulation is unknown. What's clear is that proximity is no longer hypothetical. If these patterns continue and expand, they may eventually be recognized not just as environmental anomalies, but as signatures of intent. The question is no longer if someone is out there, but if they've already arrived. As the signals grow louder in our own backyard, a far older and darker theory begins to sound less like science fiction. The zoo hypothesis reinforced. Among the more unsettling interpretations gaining renewed attention is the zoo hypothesis, a concept suggesting that advanced extraterrestrial civilizations are deliberately avoiding direct contact with humanity, observing us instead like animals in a controlled reserve. While long considered speculative, Voyager 2's recent anomalies and the broader data now emerging have pushed this theory back into serious discussion.
Of life, but a transmission, a message, one that scientists didn't expect and still don't.
If intelligent watchers are indeed monitoring us, the consistency of passive observation without interaction fits the zoo model disturbingly well. We have launched probes, broadcast messages, and expanded our technological reach, yet no contact has been made. Instead, we receive structured signals that end abruptly or shift in ways suggesting we are being studied, not engaged. The implications are profound. In this framework, Earth, and perhaps the entire solar system, functions as a controlled environment, closely watched but deliberately isolated. Just as conservationists observe wildlife without interfering, the watchers may be bound by a self-imposed directive: do not interfere until a certain threshold is met. Voyager 2's trajectory change and sensor prioritization, coupled with signals that resemble structured observation rather than communication, could be interpreted as signs that we've triggered some kind of awareness protocol, not because we are ready for contact, but because our behavior crossed a line, technological, ecological, or behavioral, that merits closer scrutiny. Are we being evaluated, or merely catalogued? This leads to another disturbing question. If we are the specimens, what is the purpose of our observation? The zoo hypothesis assumes the watchers are advanced enough to remain hidden, yet capable of monitoring every aspect of our planetary evolution. They may be assessing our capacity for peaceful coexistence, our treatment of our own environment, or even our willingness to recognize intelligence beyond ourselves. The silence in response to our outreach, the Voyager golden records, radio transmissions, and decades of astronomical messaging could reflect a deliberate withholding, not because no one is there, but because someone is choosing not to answer. That silence, when viewed through the zoo lens, is not indifference, it's policy. Critics of the hypothesis argue it is unfalsifiable, but that doesn't mean it lacks value as a conceptual model. When taken together with the sudden anomalies detected in and around our solar system, it provides a plausible structure for understanding the watcher's apparent disinterest in contact. We are not necessarily alone, but we may be quarantined. If the zoo hypothesis holds any truth, then humanity's role in the cosmos may not be that of pioneer, but of subject. The real question now is whether our behavior is being judged, and if so, what comes next? And if we are being watched, perhaps the silence isn't indifference, but a test. In that light, every signal we send, every probe we launch, might not be reaching out into the void, but performing on a stage we never knew existed. Whatever Voyager 2 encountered, it's clear we're not just sending signals into the dark. Something might be listening. If this left you with more questions than answers, you're not alone. Let us know what you think in the comments. Don't forget to like this video, subscribe for more deep space revelations, and hit the bell so you don't miss what's coming next. And now, check out the next video on your screen. It dives even deeper into the evidence that we may not be the ones in control out there.